we are going to discuss what is ocean acidification and what causes ocean acidification. We will then go on to discuss the processes of ocean acidification, so the chemical processes that goes into the ocean becoming more acidic. We will then look at what is coral bleaching and what causes coral bleaching. Then we will continue to look onto the impact of ocean acidification and coral bleaching on marine and aquatic life and on people. We will then discuss possible solutions/efforts that can be done to combat ocean acidification and coral bleaching. Then we will conclude up. Ocean acidification, also known as the other CO2 problem, is a big issue. So what is ocean acidification? So ocean acidification is the ocean absorbing excess CO2 from the atmosphere. Now, a big portion of the excess CO2 is from fossil fuels being released into the atmosphere, either from automobiles, industry, etc. So, nature, or in our case, the ocean, aims for equilibrium between the concentration of CO2 in the atmosphere. So it will absorb the excess CO2 released into the atmosphere. This increase in CO2 results in the pH of the ocean to lower. A lower pH equals an increase in acidity. So that is what ocean acidification is. On a follow-up to what I just explained, this diagram represents the carbon cycle between the atmosphere and the ocean. It is seen that CO2 flows through the ocean and back into the atmosphere. This is why the ocean wants to stay in equilibrium with the atmosphere. So an excess of CO2 in the atmosphere, the ocean will try to counteract that and absorb some of that excess CO2. Humans are rapidly increasing the CO2 in the atmosphere, which is causing the ocean to absorb this much CO2. This diagram represents a basic chemical processes that go into the ocean becoming more acidic. It starts by CO2 gas dissolving into H2O. This creates carbonic acid H2CO3. This carbonic acid can dissociate into its respective ions of bicarbonate ions or hydrogen ions. These hydrogen ions can therefore go on to bond with H2O to yield hydronium, which is a stronger acid. Also, sodium can be ignored because sodium is a spectator ion and it has nothing to do with pH. This diagram represents a similar chemical processes that go into the ocean becoming more acidic. The unique thing about this diagram is it shows that the consumption of carbonate ion impedes calcification, which can affect mollusks and various other shelled organisms. Before we ask what is coral bleaching, we must first understand the relationship between coral and algae. And that relationship is that they both depend on each other to survive. When the algae is stressed, it will leave the coral. The coral is then left bleached and vulnerable. The algae gives the coral color, helps with food, aka photosynthesis, and protects the coral. The coral can survive a bleaching, but it is at increased stress and subjugated to increased mortality rates. The most predominant cause of coral bleaching is the increase in ocean temperature from climate change. We are releasing plenty of emissions that are absorbing more heat and therefore slowly increasing the average temperature on Earth. Another cause of coral bleaching is polluted runoff. This could include pesticides, herbicides, and other chemicals that are polluting the ocean. This can also increase bleaching. Other minor causes can be excess sunlight and extreme low tides, but both of these are not major contributors. The impact on marine or aquatic life can be extensive. A first negative impact is on calcareous shell organisms, such as coral, mollusks, etc. The lack of carbonate ions yields so it is harder for these organisms to induce calcification. Coral reefs also provide a habitat for millions of marine species, roughly about 25% of the ocean. Coral acts as a protection for these small fish and for eggs. So therefore, if the bottom chain is taken out of the system based on food webs, it can be understood that the top apex predators can also be highly affected if coral reefs are taken out. Therefore, the entire food web can be affected. Also, new coral will be dissolved and old coral will start dissolving too due to the increase in ocean acidification, and the long persistence of this acidification causes extinction for many coral populations. This rapid acidification is really not allowing species in the ocean to adapt fast enough. Ocean acidification and coral bleaching also will have an impact on people, on us. First off, commercial fishing, which is a huge industry, provides a lot of revenue for the world across the earth, will take a big hit because the biodiversity that's found in coral reefs will be decreased because the amount of coral reefs will be decreased and therefore the amount of apex predators will be decreased, so the entire biome of the ocean will be decreased. Another thing to consider is most people live on the coasts, so their jobs sometimes are working out in the ocean, catching fish. Supports lots of jobs. This feeds lots of food. People are going to have to look for alternative food sources because of this decrease in biodiversity, which equals a decrease in food for humans. Also, there can be chance for huge losses in tourisms for areas with large coral reef systems such as the coast of Australia. That is how ocean acidification and coral bleaching can affect people. Solutions to ocean acidification can be tricky because, let's face it, world issues are tricky. The main goal is to reduce the global carbon emissions. This is the main problem because this excess CO2 in the atmosphere is being absorbed by the ocean. So if global carbon emissions can be reduced, a first method to solve this solution would be to fix the Kyoto Protocol and get it ratified by all nations. Improving the Kyoto Protocol and basically getting it enforced could significantly reduce global carbon emissions. Also, research can be done into microorganisms that can be added to the ocean to raise the pH. But this could have unintended consequences, but research could be done in this area. If we look at the large scale of things, if we stopped emitting carbon now, the ocean would still absorb carbon for around 50 years. So this issue is not going away. Individually, local steps that people can take could be to grow gardens, become a vegetarian, and buy local food, because when you do this, you're reducing your carbon footprint, which basically reduces the emissions into the atmosphere, which basically decreases the amount of excess CO2 the ocean absorbs. Solutions to coral bleaching can be found by first looking at the causes again. The main cause is warm ocean temperatures. So to counteract warm ocean temperatures, we must first understand why the oceans are increasing. And they're increasing because of climate change, because of the trapped greenhouse gases in the atmosphere, which traps the heat, which increases the temperature of the ocean. So the main goal would be to reduce emissions. Another main step that can be done to reduce coral bleaching would be to use less pesticides and herbicides or find alternative for those. Also, governmental research into improving management of fertilizers/pesticides polluting water can be done, and research also can be done into the hypoxic zones and understanding why there's little to no life in these areas. Locally, increase plants, conserve water, and recycle are key steps that will reduce emissions and therefore reduce coral bleaching. Overall, ocean acidification and coral bleaching are predominant issues that require our fullest attention.